Hey guys, welcome to Coderversity, the channel where we transform code novices into web wizards. I'm Abhishek Singh, and today we are diving deep into the world of Kotlin. Whether you're a complete beginner or just looking to refresh your skills, you've landed at the right place. Before we get started, make sure that you hit the like button and subscribe to be notified when more crash course videos like these are released. So grab your laptop, a cup of coffee, and let's get started. Kotlin, my friends, is a modern programming language that runs on the Java virtual machine. It is used primarily for Android app development and offers concise syntax and interoperability with Java. Here are some applications of Kotlin. Kotlin is not merely used for Android app development, it can also be used for server-side applications, web development, desktop applications, and data science. Now comes the question, why use Kotlin in the first place? Because Kotlin is concise in syntax. Null pointer exception, which is a big headache for developers, is solved by Kotlin's null safety operators. Kotlin is interoperable with Java. It offers modern language features, unlike many programming languages. The community support for Kotlin is amazing, and it is backed by Google. And performance of Kotlin, of course, it is unmatched. First things first, let's set up our development environment for Kotlin. And for this, you would need the JDK. Remember, I said that the Kotlin is programming language that runs on the Java virtual machine. And therefore, you need the Java environment to run your Kotlin code. And so we download the JDK first. And then we also need an IDE where we will write our Kotlin code. And for that purpose, we use the IntelliJ IDEA. So as I said, first up, we need the JDK. So let's head on to Google, search for JDK download, go to the Oracle website, and there you have it, a list of installation files for you based on your operating system. Select the right one. If you have Mac, choose one of these. But I have Windows, I'm going to just select the x64 installer, and I'm going to save it and let it download. Now that we have the JDK downloaded, I'm going to open it and run the installation wizard. There you go, we have the installation wizard. I'm going to hit on next, and you can select the folder where you want to install the JDK, and then click next and let it install all the necessary components. And there you have it, the JDK has been installed. Okay, great. Now head over to Google again, and now we need to download and install the IntelliJ IDEA. So we're gonna just look for IntelliJ IDEA download. Here we have the JetBrains website. Go to the website, and then important thing to understand here is that this is an IntelliJ IDEA Ultimate version. It comes with a free 30-day trial period. Okay, if you want to go with this, you can choose it, but after some time it's not going to be free. You need to buy it. So for that purpose, I would recommend you to go to other versions on the right side and look for the community edition, and then simply install the one that's available, and depending upon your operating system, select the one that's available. So here we have the x64 version. I'm going to choose that, and I'm going to download it. Now that we have the IntelliJ IDEA downloaded, you can open the executable file, and let's go through the installation wizard to install the IntelliJ IDEA Community Edition. Here you have it, the installation wizard. Select next, choose the destination folder where you want to install the IntelliJ IDEA Community Edition, and then click next. If you want to create a desktop shortcut, which I want to, so I'll select that, hit next, JetBrains, and then let it install the components necessary. And there you go, you have it, IntelliJ IDEA Community Edition setup complete. We click on select this and finish. So now that we have our environment set up, let's begin with the classic Hello World program. And for this, select on new project. It will detect the JDK, and then you need to name your project. You can name it anything you like. First Hello World, I'm just gonna call it, and then make sure to choose Kotlin here in language, and IntelliJ, of course. JDK should be detected correctly. You can select this add sample code just to make our job easier, and let it load up the project. So the project has finished loading up. You can remove this piece of code. We just need this 3 lines of code here in our main.kt. And where is this main.kt? So here you have the project file. Inside the main you have Kotlin, and then there you go, main.kt. Your program file is right here, the Kotlin file, right? So inside this there is this 3 lines of code which I'm going to explain now. So first of all, you have the fun keyword, which is basically used to declare a function. A function is a block of code designed to perform a particular task. In every single Kotlin program, you have a main function, which is basically the entry point of every program, right? And there you go, the arguments for this function. And then we have this statement, println statement, which is used to output values or print text. Note that it will add a new line at the each function execution, right? So after printing hello world, it will create a new line in the console, goes to the next line. If you do not want that, you can simply use print instead. But to set just this example as simple as possible, we are going to just go with whatever code we have gotten from Kotlin end. And yeah, let's run this code and try to see what happens. And there you go, hello world is printed onto the console like so. Okay, right. So now that we can print a text into the console, let's move on to variables and data types in Kotlin. In Kotlin, variables are used to store and manipulate data. A variable represents a named memory location that can hold a value of a specific type. Variables are essential for storing and managing data throughout the program execution. In Kotlin, we have 2 types of variables. One is a mutable variable and immutable variable. Let's look at an example to understand this better. Okay, so in the main function, I'm going to declare some immutable variables first. So here we have the val keyword written to declare it's a variable of immutable type, and we name this variable as name, and then we write the type of the variables, which is string, and then we say equals to John. So this is a first immutable variable, and then we got mutable variable, which is declared with the keyword var, and age of the type integer, and we have 30 as a value given to this variable. Now, what's the difference between immutable and mutable variable? If I were to write name equals to, let's say Max, what would happen is the IntelliJ IDEA would tell us, well, you cannot do that. It's a val. You cannot change its value, right? But so this is what an immutable variable does. With a mutable variable, if I were to change the age to 25 or something, it would allow me to do that. There is no error as such, right? So this is the difference between mutable and immutable variables. You can change the values of mutable variables, right? But you don't need to always define the data type of the variable. You can also use type inference, like in this example. So if I say just val country equals to the USA, it would simply understand that it is of the type string, and that string type would be assigned to as a data type to this particular variable, right? So that is called type inference. And then we have nullable variable, which is quite interesting. So if I were to declare a variable of the type string and give it a value as null, okay, so we encounter an error. It says that null cannot be a value of a non-null type string, right? So I cannot simply assign a null value. Well, then we need to inform, but it can happen during program execution, and the program would crash if it encounters a null value, let's say. So to handle this situation, I would use a question mark here, which is a nullable operator. It tells the IntelliJ IDEA, well, wait, the variable job of the type string can have null values, and when they do have null values, do not crash on me, give it a null, and continue execution of the program, right? So that's what a nullable variable does. Right, so now that we can work with variables, let's explore conditional statements in Kotlin. I'm going to remove this code first, and let's talk about the conditional statements. So if-else statements are used to control the flow of the program based on certain conditions. Okay, so it is called conditional branching. So let's have a look at an example to understand this better. Let's name a variable called val number is equals to 10. Because of type inferencing, it would understand that it is a type of integer. And then now I give an if condition and say number is greater than 10, and then I have open braces, and I write println the number is positive, right? So here's what happens in this if statement. It basically checks for this condition. If this condition is true, it evaluates the block next to it. It executes this block. If it is not true, this condition evaluates to false, then it would not execute this block. Okay. However, if in case this block does not get executed, we can have another block based on another condition. So we have println the number is negative. And finally, let's have another block without condition this time. It's a println, well, the number is 0. There you go. So in this particular case, in the if statement, it checks for this condition. If this condition is evaluated to be true, then it executes the block next to it, skips the other blocks. Then comes the else if statement, where it again, like if in case this block was not executed because this condition evaluated to be false, it checks for the next condition in the else if block. And here it checks for the else if block, and it checks for another condition given right here. And if this condition evaluates to be false, or evaluates to be true, then it executes the block next to it. In case it does not evaluate to be true, then this block is automatically executed without checking any conditions. Okay, so only one of these blocks is executed. And let's run the program to check how this works. So the number is positive, it says, because 10, as you know, is greater than 0. So the first block was executed, rest of the blocks were skipped. If I were to write minus 10 instead over here and I run the code, it would give me the result in the console being the number is negative, right? Which is obviously the case because minus 10 is indeed less than 0. Whereas if I were to give the value as just 0, then if I run the code, it would obviously not execute the first block of code, the second block of code, because both the conditions are false, and automatically execute the third block of code, which is that the number is 0. Great. So, like I said, in Kotlin, we use if-else statements for conditional branching. Here we check whether the number is positive, negative, or 0 and print the corresponding message onto the console. Next up, let's talk about loops. Loops are used to repeat a set of instructions until a certain condition is met. Kotlin provides two types of loops. One is a for loop and second one is a while loop. Okay, so let's dive into loops. And let's look at an example to understand this better. I'm going to delete all this code and let's start with a for loop. So I say for loop in the comment, and then we have for loop with the conditions saying I is in between 1 to 5. So in this condition, I variable is initialized with the value 1. It keeps incrementing after every single iteration of the loop and until it reaches 5. When it reaches 5, it does not get incremented and it comes out of this loop. Okay, so this is an example of for loop, and here we are saying println current number is $I. Okay, so let's execute this piece of code and see what happens. So as you could see here that in the for loop we have an initialization step where we set the value of I to be 1, then a condition to check if I is in between 1 to 5 and 1 and 5 included, and then we have an increment and a decrement step. So we have increment step here where we say I is incremented after every single iteration of the loop. So I is incremented from 1 to 2 to 3 to 4 to 5, and it is printed onto the console thanks to this statement given here, right? So that's your for loop. Okay, but there also can be a while loop, right? So let's talk about that now. In case of a while loop, we execute a block of code repeatedly as long as a given condition is true. But initialization does not happen within the for while loop condition itself. So where we write while count, var count equal to 0, this is a variable count, and now inside the while loop we just have a condition which checks if the condition is true. Then we execute a block of code which says println count $count, right? And of course, after every iteration of the loop, we go count plus plus. we are incrementing the value of count. And this is an example of a while loop. If you run the code, you would see we have the count initialized from 0 like here, and then it is incremented with the post increment operator given in the third line of this second line of this block, and where we increment the value of count from 0 to 1 to 2 to 3 to 4, and as long as this condition is true, this loop iterates, and of course we print the value of count along with it, and once the condition becomes false, the loop terminates like so. Okay, so that's what we see over here. But these are not the only two examples of for and while loop. We also have a do while loop to consider, right? So what happens in a do while loop? So this is an example of a do while loop. We have a block executed first and then we check for the condition, okay, unlike a while loop and for loop. So we have a condition. Let's say we're working with count and we say count is less than 0, just an hypothetical situation, and I'm just gonna write then print the value of count, or we can say do while count, and we set a dollar count, right, like so. And if you see right at the spot, like the count value was 4 at the end of this while loop, and so when it checks for the condition here, it was evaluated to be false. So does this block execute or not? Let's check. So if you see, the block was executed once and not after that. So this is what happens in a do while loop. The block of code gets executed next to the do, and then we check the condition. If the condition is false, the next iteration of the loop does not happen. So this is an example of loops. Let's head on to the next example, which is functions. All right. Functions, my friends, are reusable blocks of code that perform specific tasks. They help in organizing code and promoting code reusability. In functions, we also have parameters, which are the input values that a function can accept. They allow us to pass data into the function to perform specific operations. Parameters are defined inside the parentheses after the function name. Okay, right. So let's have a look at an example to understand this better. If I were to have a function with the name add, right? If I were to give it two parameters of the type integer, we have a and b of the type integer, and we have the output, meaning the return type of this function, to be integer. We define it like so, and then we say return a plus b, right? Great. So of course this is an example of a function where we are giving two parameters as input to this function a and b, which are of the type integer, and we are giving the output of the function to be integer as well, defined right here in the same fashion, and then we are returning the sum of the input parameters a and b. And then we have multiply as another function where we put x is int, y is int, and there we go. We return x multiplied by y, right? So the product of, again, I did not define the return type of this function, so I'm going to write :int. So it takes in two parameters x and y, multiplies them, and gives us the output, right? So this is how a function can return a value. It's not necessary that a function returns a value. If it is a void, or which we define as unit, it does not return any value, but in our case it does return a value. So we're gonna have a look at an example of how it does that. So we have a variable in the main function with the name sum, and it is given the value add 2 or we can say 5,3 5,4. Okay, and then we say println, we are printing the value of sum as sum colon. This is an example of string interpolation, defining a variable inside a string. When you want to do that, you can just put a dollar next to the variable name. It would use the value of the variable inside the string. But this is an example of a string interpolation that you can do in Kotlin. And then the next one, I would say result, is multiply 2, 4. Then we have println, the result is dollar multiply. Dollar basically you can say directly, use it directly if you want, like just like we did now, but you can also write it like the way we did it in previous example, result. Okay, great. So I run this code and let's see what happens. There you go, you have the sum printed as 9, so you know the sum of 5 and 4 is 9. So this function was executed pretty well. 5 and 4 went as parameters, and then they were added here and given as output. Multiply, the same thing which happened here, 2 and 4. 2 multiplied by 4 happened here, and it was given as a value to the result variable, and the result was printed as 8. Okay, so in Kotlin we define functions using the fun keyword. We have two functions, add and multiply here, and add takes in 2 parameters and returns the sum, whereas multiply takes in 2 parameters, gives the product. But well, we can do it differently as well. You don't need to exactly do like this. There is also a way to create a single expression concise function, because I told you Kotlin saves you to write a lot of code. So we just say x into y and like this, and give it a value like this. And if we do that and I run the method, you would see that it would print us the result like it happened the previous time. 2 multiplied by 4 is 8, and gives us the result correctly. So that was fun. Let's head on to the next topic, classes and objects. Okay, so Kotlin is an object-oriented programming language. Okay, and therefore it's important to understand classes and objects when we're talking about Kotlin. Object-oriented programming is the programming paradigm that organizes code into objects, which are instances of classes. Object-oriented programming emphasizes the concepts of encapsulation, inheritance, and polymorphism to create reusable modular code. Classes are blueprints or templates that define the properties, which means the attributes, and the behaviors, which means the methods of objects. And what are objects? Objects are instances of classes that represent the specific entities. Let's make an example to understand this better. We go to Kotlin, right click over here, create new Kotlin class or file, and then let's create a class called person. Okay, like so. So in Kotlin we use the class keyword to create to define a class. Here we are creating a person class, and inside this we have a variable with the name of the type string, and it is given an empty value. And then we have a variable of the name age of the type integer, and it is given 0 as its value. And then finally we have a function called greet, where we are giving println, hello, my name is $name, right? Like so. So these variables with the name and age given here. Okay, so these are the attributes of this of the object that we will create, which will be an instance of this class. And greet is a method which basically is the behavior of that object, right? So this kind of represents a real world entity, isn't it? Instead of using just the variables and methods that we have been using before, right? So let's create an instance of that class, which is called an object, by writing person. So we write val person, which is basically the object of the class person. Okay, and we say person dot name equals to John. So we are assigning a value to the one of the attributes of this object, and then we have person dot age equals to 25. And of course, then finally what we do is we call the function, which is basically a behavior of this object called greet, and we are running this function by clicking the green arrow button, and as you would see, it prints hello, my name is John. So we assign the value name to the John. Okay, and then the name and age were properties of that class, and greet was a function which is a behavior of that object. So we create an instance of that class and call the greet function, which basically uses the name variable and prints it. There you go. And now we also have a topic to talk about, that is null safety. Okay, so I'm going to delete all this function, all this code, and let's talk about that topic. So this is one of the great advantages of Kotlin, that Kotlin provides powerful null safety features to prevent null pointer exceptions. Before that, what are exceptions? Exceptions are the events that occur during the execution of the program, which can disrupt the normal flow of the program, and this needs to be handled because the program can crash. And some examples of this you can understand is like when a number is divided by 0, that is an arithmetic exception. Then we have null pointer exception, when the program encounters a null value, which is a big headache for developers, especially Android developers. And then we have file not found exception, and so on. So these exceptions need to be handled, otherwise our program would crash. And therefore, let's have a look at an example to understand this better. So let's call a variable with the name as, with the data type as string, and then give it null as a value. Have a look at what happens here. Null cannot be the value of a non-null type string, right? And so we choose question mark here to tell the IntelliJ IDEA that this variable is nullable, meaning it can't have null value, so this would not throw an exception. Okay, great. Now let's talk about something more interesting, which is a safe call. So we have a variable with the value length equals to name question mark dot length, right? And have a look at what happens here. Either with the safe call you get the length of the string, or it returns a null without crashing the program, without causing a null pointer exception. Okay, so I'm going to print the length saying name length is, with the string interpolation, length, like so. But this is not the only way. So either it would print the length of the string, or it would just say name length is null. Okay, and then we have something else that we can do when we encounter a null value, which is Elvis operation, right? Elvis operator. So when we want to use a save call, we use a question mark with a dot. But when we want to use else operator, here's what we do. We have a variable called length or default, meaning that when we'll try to get the length of the string like we did in previous example, and in case it turns out to be null, we tell the compiler, well, then take the default value, which is -1, right? So either the value of the length of the string is the length itself, but if in case the string itself was null, then in that case assign -1 to the length of the string, length or default variable, and then we print it saying name length. I'm just gonna say name or default is length or default, like so. Okay, so either the name.length, this particular statement will give us the value of length or default to be null, or -1, which is a default value. Great. Let's have a look at another example, which is not null assertion. Right, so here we try to assert or try to tell the compiler, well, you see here we are not having a null value, and we using this double exclamation mark, okay, to the name, and if in case it does become null, you have to be careful because that could lead to null pointer exceptions. Okay, but we're trying to assert nullable value to which and is not null. So we are printing it. We print not nullable name dollar non-nullable name. There you go. So if you run this program, you would see what happens in each and every case. So first up, the name value was null that we defined in the beginning itself. And then we do a save call and we print the length of this string name, and it just returns null. It doesn't throw an exception. But in the second case, where we use the else operator, I said either give me the length name of the length or give me a default value, which is what an else operator does, a question mark with a colon, and it gave me -1 as its value because, well, it is having the default value in case of a null pointer exception, right? In the third case, here what happens is we are using a not null assertion to assert that a nullable value is not null, but we have to be cautious with this because this can lead to null pointer exception like we have it here in the third case. Okay, so this was about null safety operations and how to avoid null pointer exceptions. Let's head on to the next topic, which is collections. Now, collections play a crucial role in any programming language. Let's explore how Kotlin handles them. So collections are containers that hold multiple values. They provide convenient methods for manipulating and accessing data. We have three types of collections. One is a list, which is an ordered collection of elements that allows duplicates. We have a set, where we have unordered collection that does not allow duplicates. And then we have map, which is a collection of key value pairs. Let's take a look at an example to understand this better. I'm going to call val numbers a variable, and this is basically a list of 1, 2, 3, 4, 5 different values. Okay, imagine without this list, without this collection, I would have written 5 different variables to store these. And what if we have hundreds of such values, right, to work with? So therefore we use a list like so, and then this is how we iterate over the list. So we have iterating over a list with the use of a for loop, which we learned. So we have number in numbers, and this goes through each and every element of the list, and then we say println number $number. There we go. So this iterates over the list and prints each and every element of the list. Notice that this is immutable, meaning I cannot change the values inside this list. Okay. Now look at this, what happens when I'm iterating over the list. It just prints all the elements one by one until all the elements are finished, right? And if I were to add anything to the list, let's say I want to add numbers dot so if I want to add elements or remove elements from the list, I cannot do that because it's a immutable list. If I were to have a mutable list, then maybe it can happen. So for that we say num, just an example, mutable list of, and you can then define 5 variables or more than that, and then you can change, you can add some elements to the list at a particular position, and you can also remove them. So that is an advantage with the mutable list if you want to work with that. But there are some operations that we can perform on lists, like filtering elements. Okay. We have even numbers, which we say numbers dot filter, and they give it a condition that the elements in the list should not be, if it is an even number, which is 0. Okay, there you go. We print the even numbers in the list using a filter like this, and we like this. Okay, so this was an example of doing that. Then let's talk about mapping elements as well. So for mapping elements, we use val squares, which basically returns so the value squared. Okay, all the values in the list squared. How do we do that? We do that with the help of map function. It goes through each and every item in the list and multiplies it by itself. This it that you see here is basically representing each element of the list, and then we are printing the result. Of course, is saying squares colon $square, and there you go. I'm going to run this program, and you would see like so. So it iterates from 1 to 5 like this, and if you want to just get the even numbers, we use this function, filter function, and it returns us the even numbers 2 and 4. And if you were to map the elements in the list, it can do that as well, multiplying its elements by itself like this. So squares, and we have 1, 4, 9, 6, 16, 25, which is basically the square of each and every element. Right? That was fun. Now let's move on to another topic, which is extension functions. So one of the Kotlin's powerful features is extension functions. Let's see how they can enhance our code. So for this purpose, I'm going to write an extension function where we do a string dot is palindrome, and we return boolean as return type for this particular function. We say val reversed equals to this this dot reversed, right? And of course they're gonna return it. So if return this or return reversed, okay? So this will return the object if it is equals to reversed, okay? Right. So if both are equal, it would return true. If both are not equal, it would return false. Okay, so that's the condition we try to return. And so we have val word1 equals to radar. Okay, this one variable, and then we have word2, which is equals to Kotlin, right? And we are trying to print it $word1 is a palindrome. So we have $word1 dot is palindrome, okay? And then we try to print the same for word2. Word2 string interpolation is a palindrome. We check it, the question mark $word2 dot is palindrome, right? So in Kotlin, we can extend existing classes with the new functions using extension functions. Here we add this isPalindrome function to the string class, and this function checks if a string is a palindrome and returns a Boolean result. So in case it checks for both radar and Kotlin, if each of them is a palindrome, and using this function isPalindrome, which is an extension function, we are trying to see if the variable is a palindrome or not. Let's run this function to check out the output. And as you could see, radar is a palindrome, question mark true. So yes, radar return was a palindrome, but that was not the same with Kotlin. Kotlin is a palindrome, false. So when we reversed Kotlin word and the result was not equal to its initial form, therefore this function which was added to the string class returned false as its output. So this is an extension function. Great. Let's head on to the last topic of this session, which is exception handling. Exception handling is vital to ensure our programs can gracefully recover from errors. Let's learn how Kotlin handles exceptions. Okay, so we have already seen how null safety works, but in case of other exceptions, how does Kotlin handle it? So let's take a look at an example to understand this better. Let's say I have a function called divide, which is of the type integer, and b is of the type integer as well. And of course this function should return us an integer as well. Okay, now if b is equal to 0, okay, I wanted to throw an exception, because what we are trying to return here is the division of a by b, like so. And as you know, this program would crash when b is equal to 0. So to handle that, we throw an exception, okay, illegal argument exception, and then we say division by 0 is not allowed, right? Like so. In the main function, I create val result divide 10, 0. There you go. And we have println result. There you go. It prints the result of division of 10 by 0. Okay, right. So if we were to directly run this code, we might encounter an exception, and let's just run this code to see what happens. Okay, so you see we just encountered a crash. This was a breakpoint, and this gave us an illegible argument exception, right? So in order to handle this crash, what we do is we are basically going to right click this, and we go to the, either we can do that, or we can just go surround it with a try catch block, right? So we say try, and we put in this code, and then we write a catch block where we say exception. Okay, E, which is of the type exception, like so, and in the handling the exception, we print exception, the $E dot message inside braces. There you go. Right. So in Kotlin we use a try, catch, and throw to handle exceptions. Here we define a divide function that throws an illegible argument exception if the second argument is 0. We then call this function within the try block and handle the exception in the catch block. So I'm going to run this code, and let's see the output. So you see exception division by 0 is not allowed like we have defined it here. It handles the exception, and it's continues the code. So that was fun. And there you have it, a crash course on Kotlin. Again, please share this video if this was helpful. Hit that like button and subscribe. Don't forget to hit the bell icon to stay notified on future videos. Until next time, happy coding.